Hi guys, today we shall say how to use xflr5 software. Here we shall design our own airfoil and try to analyze our airfoil using this software. So before getting into this, we shall say what is knockoff 4-digit airfoil. So first we shall see the basic nomenclature of an airfoil. So airfoil can be characterized based on chord length and camber. The chord length is the line that joining the leading edge and the trailing edge. And length of this chord line is chord length. And camber is camber is a line that is a midpoint between the upper and lower surface of the airfoil. So generally, Naka 4-digit will be having a name start from Naka followed by 4 numbers. The first two digits describe the camber as a percentage of the chord. And second digit describe the distance of the maximum camber from the leading edge. And the last two digits describe the thickness of the airfoil as a percentage of the chord. For example, a knockoff 2412 airfoil has a maximum camber 2% located at 40%. Or you can say 0.4 times of the chord from the leading edge. And it has 12% maximum thickness of 12%. So here it has a camber of 2%, which is located around 0.4% of the chord length, and the thickness to chord ratio is 0.12. So this thickness to this length, the ratio between this length to this length is 0.12. So this is how we name the name on airfoil based on knockoff 4-digit series. So now we shall see how to use the XFLR5 to design an airfoil. To download the XLR5, so just you have to Google it, FLR5 software download. The first link, if you right click and open the first link, it will open the page like this. You can download the software by clicking download option. It will download a zip file. So if you extract the zip file, you'll be getting a folder like this. To launch the XFLR5 software, just go to the folder and open the xflr5 exe file. So this is the interface of the software. Now we shall see how to use one airfoil. For that, go to modules, click on direct airfoil design. So by default, you will be having an airfoil like this. This is spline airfoil. These are the control points of this spline. So you can make your own airfoil by changing the location of these control points. So once you go closer to this control point, it will become red. Then you can click and drag that point. So if you want more control points, you can click on the airfoil surface, then right click, go to splines, then insert control points. So now you can notice it has inserted a new control point. So you can have a better control of this curve by modifying this. Once you're happy with the airfoil shape, you can save the airfoil by clicking this icon. Now it's asking to save. I'm saving this airfoil in the new name. So here I'm just giving one name, spline file 1. And if you click OK, that is displayed here. So this is our new airfoil. Now we shall try to analyze our airfoil using xflr5 software. For that, we should click Modules, X for Direct Analysis. So then now we should start the new analysis. For that, click Analysis, then define on analysis. So here you can give your own name for the analysis. And you can also specify the Reynolds number for this analysis. Now we shall see what is Reynolds number. So Reynolds number is a non-dimensional number generally defined based on the ratio between inertial and viscous force. The formula for the Reynolds number is rho u L by mu, where rho is density, u is speed of the flow, and L is the characteristic length of the characteristic dimension of the flow, and mu is the dynamic viscosity. Generally, for airfoil and those things, airfoil we use the chord length. This chord length is a L value. But if you are analyzing a flow inside one pipe, we use diameter as a characteristic length. This characteristic length is determined by the nature of the flow. Depends on the flow, we should pick the appropriate the characteristic length. So right now I am just using the Reynolds number, the default Reynolds number, that is 1 lakh. Then if we click OK, so we are okay with our simulation. Now we shall run our simulation. First we shall run one simulation for one particular angle of attack. So for the time shake, I am using angle of attack around angle of attack 5. Angle of attack is angle between the relative wind and the chord line. That this angle we call as angle of attack. And if we click analyze, it will complete the analysis. So the analysis is over. Now we shall see the different parameters. Here you can notice the CL, our angle of attack is 5, and the coefficient of lift, that is CL, is 0.782, CM is coefficient of moment is minus 0.025, and coefficient of drag is 0.020, and this has an L by D value of 38.856. So these are the parameters of our, aerodynamic parameters of our airfoil. So now we shall try to find the CL versus alpha curve using this software. For that, click sequential, and here you can specify the different angle of attack we like to simulate. For the time shake, I am giving -10 as a starting angle of attack and 20 as a end angle of attack with an increment of 1 degree. So if I click analyze, it will analyze the flow. So you can notice that it's analyzing the flow for different angle of attacks. So this is the polar plot means CD versus alpha curve. So you can notice we are having drag bucket. That means it will be a U kind of shape, parabolic shape. That means you can write CD is equal to CD naught plus K into CL square. Now we shall see all the graphs. The first one is CD versus alpha curve, and second one is CL versus alpha curve, and third one is CM versus alpha curve. Generally for an airfoil, we will be trying to optimize an airfoil for higher L by D value. But if you want to make an optimization of an airfoil, you can explore the module xflr5 inverse design. We shall see another tutorial how to make our own airfoil by using inverse design. So let's say I want to save this image and this save you to image file. You can save like this. So once you have to save the file, you can open the file. So right now I have saved this file in data folder. You can also export the file in Excel or CSV format. So for that, right click, current xfile, export, and you can give the name of the file. So I want to save this in this folder. So I'm copying the path. So this is a file. So we can open the file in our favorite notepad, text file editor. So this is the air file information. So we can delete this one. You can open Excel to visualize this result. So Excel is ready to use. We can open up our file data we have exported. So let's get into the folder because that the CSV format is not showing here. So we can click this one, then all files. So this is the file we have exported from the software. So here delimiter fine, that is space. That that's a comma separated for is the data format which separated by space. So we have chosen space here. Now if we click finish, it will show the airfoil coordinates. Now we shall plot this curve using Excel. The coordinates and insert scatter plot. So this is a this is a coordinates of our airfoil. Now we shall see how to export the these parameters, CL versus alpha and other parameters. For the right click this airfoil, current graph, export graph, and we can give some name. For the time shake, let it be graph, polar graph 0. So we shall open the graph. So this is the CL versus alpha curve. Now we shall plot this curve by clicking insert, chart, scatter. So this is a CL versus alpha curve. So using these ways, you can export the airfoil data as well as you can also export the performance, aerodynamic performance of an airfoil.